A bag is tied to the top of a 5-meter ladder resting against a vertical wall. Suppose the ladder begins sliding down the wall in such a way that the foot of the ladder is moving away from the wall at a constant rate of 2 meters per second. How fast is the bag descending at the instant the foot of the ladder is 4 meters away from the wall? Our first step in solving related rate problems is to draw a diagram. We know that the ladder is a constant 5 meters. It's not changing. What is changing is the distance away from the wall. So we're going to designate that with the variable of x. And also what's changing is the height. The ladder's sliding down. So we're going to designate that with a variable of y. I know there's a temptation to substitute 4 in right away, but hold off on that. We want to do our substitutions after we differentiate. That comes up later into the process. Now that we've designated our diagram, we want to talk about the related rates. We want to talk about the rates of change. So this says that the ladder is moving away from the wall. That's a horizontal change. Okay. We also want to talk about the constant rate of change, which is 2 meters per second. Okay. Since it's a horizontal change, we're going to refer to that as dx dt. How is x changing over time? So that's known, dx dt. What we don't know is the change in height as time progresses. So dy dt is unknown. How fast is this ladder coming down the wall over time? And what we're looking for is the specific change at the instant the ladder is 4 meters away from the wall. That's what we want to find out. Now, the wall and the ground form a right triangle. So since we have a right triangle, we can use Pythagoras Theorem. And we know that relationship is x squared plus y squared is equal to 5 squared. Let me just pause to note that we already know at some point x is going to be 4 meters away from the wall. At that instant, y is going to be 3 meters from the ground. That's going to come up later when we substitute. This is a 3, 4, 5 right triangle. Now we can differentiate. The derivative of x squared is 2x dx dt. The derivative of y squared is 2y dy dt. And the derivative of 5 squared is 0. This is where we do our substitution. We want to find out the change in y with respect to time when x is 4. So I replace x with 4. We were given dx dt is 2. And we also know at the moment the foot of the ladder is 4 meters away from the wall. The height of the ladder is going to be 3. It's pretty easy to figure out that at that point, dy dt is going to be negative 8/3. So the bag is sliding down the wall at a rate of change of 2.667 meters per second when the base of the ladder is 4 meters away. I underlined the word down to take the place of the negative up here.